Hey guys, hope you're all doing good and welcome to a new video. So today I wanted to give you a practical example of coordinate transformation. So here what I have is I have a two-dimensional space and a replica of that is here. Okay. Now I actually have four position vectors, right? So essentially for each and every point here I have the vectors. Alright. So now assume that there is a coordinate system that's attached to this particular box here. Okay. And if I am rotating the coordinate system, right, for example, take this box and say that I'm rotating it by 45 degrees. The relative position of those points with respect to each other is not going to change if I'm rotating all the points by the same amount, right? So the question is, now say that you are in the rotated coordinate system. Okay, so for example, in the original coordinate system, this point is 0, 0 and this point is 0, 1. Now, if the coordinate system is rotated by 10 degrees about the origin, then what would be the coordinates of this point? And that's essentially the problem of coordinate system. So, for example, if the coordinate system was rotated by 10 degrees, okay, in the original coordinate system, this point is 0, 1. But if the coordinate system has been rotated by 10 degrees, meaning assume that this is x-axis and this line right here is y-axis, right? Now, in the new coordinate system, the position of this point is still the same. It is still 0, 1, right? Because when the coordinate system rotates, this point still stays in the same place. But with respect to your original coordinate system, this point has now moved. And you can see here that this is what I'm calculating here. So I have in the first four lines here, I have the coordinates of each and every point. So this would be 0, 0, and that's typed here. And for this point, it's 0, 1. And this point it's 1, 1, and this point it's 1, 0, and then finally coming back to the origin to close the loop 0, 0, right? Now when I rotate this by 10 degrees, you can see that the first and the last points don't change because they are origin, but the other points are actually moving, right? And you can see that it's essentially a combination of cos and sine transformation, right? Which we derived. We essentially derived that for just the x coordinate, right? And I told you that in the previous video that we could derive the same equation for the y coordinate as well. What I've done is I've just derived it and essentially I've put in the formula. So for x coordinate, you can see that the formula is cos theta times the coordinates plus sine theta times the coordinates, whereas for the y coordinate there is a minus sign, okay, that comes out. But essentially that's the transformation that I apply for all the cells, and I'm able to do this. So what I would definitely encourage all of you to do is build up an Excel calculator like this, derive the coordinate transformation equation so that you can essentially see what happens when you rotate the coordinate system and what happens when you rotate the coordinate system and how the coordinates of each and every point change with respect to the original or the global coordinates. Okay, with that I would like to conclude this video and I'll see you guys in the next one. Thank you. Bye.